Hyderabad Center for Excellence in Nursing Education and Service. Today, we will be dealing about the graphical representation of data. In the previous classes, we discussed about the different way of representing data. One of the method which adopt not only in the research field, even in the political or the administrative level or in the economical way, we commonly use this graphical method to represent the synthesized data. So, today's sessions we will be dealing why we use and the different types as such. Okay friends, let's see about the graphical representation. What do you mean by graphical representation? Here we use graphs to represent the data, especially to show the relationship of variable with others, and we use here commonly two axes. The horizontal axis in the graph, it is known as the x-axis or the abscissa, and the vertical line is called ordinate or the y-axis. And in the graph, we use a point which cut each other, both x and y axis, and that point of it is known as the point of origin. And we could see on the right hand side x value which are on the positive, on the left hand side the x value is negative. Similar way, we could see abscissa and ordinate divide the graph paper into 4 parts. That is first coordinate, second coordinate, third coordinate and fourth coordinate. 2 positive and 2 negative coordinates we have it. And when we select the scale, we should be very carefully select the scale to accommodate all the data. And always we represent independent variables in the x-axis and dependent variable on the y-axis. And usually other points we need to remember when we represent graphic. And on the horizontal axis there is no need to begin with 0, but y-axis always have the 0 point as the origin. Now let's see the different types of graphical representation. There are different types like histogram, frequency polygon, frequency curve, line graph, or guides, that is mainly less than guide or more than guide. These are the commonly used graphs in the nursing field. Let's first see the histogram. What do you mean by histogram? In the previous session we have seen the bar diagram. More or less it is similar, but the histogram represents for the continuous data. Here we can see histogram is the graphical representation of frequency distribution consisting of series of rectangles. It is constructed from a frequency distribution of group data whose width represent class interval and the area is proportional to the corresponding frequency of a particular data value. And it's a special kind of bar diagram for a frequency in continuous scale. And rectangles are prepared over this class interval. histogram. To construct a histogram, the class interval should be max in x-axis and the frequency is represented in the y-axis. For example, let's have a look on this one. Here we could see the histogram representing the prevalence of hemoglobin level. And we could see that on the x-axis it is not starting from 0, but on the y-axis we could see that it is mainly start with the 0. So x-axis values are 5 to 7, that is the first class interval. There are 15 people. On the y-axis we could see that 15, it is represented. And the next class interval is 7 to 9, and there we could see that 20 people are there. Frequency is 20. And similar way, 9 to 11 is the next class interval, and again the frequency is 30. So on the x-axis, hemoglobin level, which is with the class interval, it is shown, and the number of people or person or the frequency is represented on the y-axis. So histogram look like this way. Hope it is clear. Next one is the graph of frequency distribution. This graph of frequency distributions are commonly like frequency curve and frequency polygon. So here in general, frequency distribution of all types are represented means of graphs, which is used to represent the data representation. The use of discrete series an item which cannot assume in a classical interval, and the value of each items are fixed and defined, whereas continuous series is an item which can assume any value within that particular class interval. And discrete series are usually in the shape of bar frequency, as we discussed in the previous class, whereas the continuous series are usually shown by means of smooth curve. So here let's discuss some of the characteristics of frequency distribution. Some of the characteristics of frequency distribution: we can measure the center tendency in terms of location, position and average, and degree of scatteredness of the observation like variability, dispersion, how it is spread. Next is the symmetry of the shape of the distribution like skewness and the peakedness of the kurtosis. So these are all things we can. So now here the first one is the frequency curve. What do you mean by a frequency curve? It is same way. When the total frequency is large and the class intervals are very less, we have the frequency curve which is smooth the surface, and this limiting condition is known as the frequency curve. In this curve, the points are proposed instead of rectangle, and all the points are joined with a straight line. Let's see how it is. So here frequency is large and the class interval is allowed. Frequency curve will have a smooth appearance, and which is by joining the midpoint of with a straight line. And here the frequency curve, they are used to there are two types: bar frequency curve. So it is used to depict the discrete series, and this look like. So midpoints are joined. So same bar histogram. Here the midpoint, same class interval, same thing about the hemoglobin status, where we could see that 5 to 7, here the midpoint, it is represented at the 15. So all the midpoints are pointed, and with this straight scale we join with the straight line. Then we get the frequency curve. So frequency polygon or the discontinuous curve, it is plotted with the straight line, and it is not a smooth one, and it is a line chart of frequency distribution. Either value discrete variables or the midpoint line plotted against this frequency by a straight line. And it is do not start from 0 and do not end also at the 0 point. But this curve can be enclosed so that starting point is joined with an assumed preceding point whose value is 0. This enclosed diagram is known as the frequency polygon in case of discontinuous curve. So that is about the frequency curve. Next, shall we look back to the frequency polygon? What do you mean by frequency polygon? It is nothing else. The rectangles selected over the interval points are plotted at the midpoints in a histogram joined by a straight line. See. How it is. Frequency polygon look like. On the other hand, when we have continuous curve, a smooth frequency curve, it will be frequency polygon is obtained by joining the points with the smooth curve. And it represents the continuous series. The top of the curve is smooth and generally be above the highest point of the frequency polygon. And the curve will be regular and smooth and should not deviate from the original shape of the curve. The extent to which smoothly can be done depends on the type of data that are being represented. And it's always better to first draw a frequency bar diagram, then join the midpoint of the bars to get a frequency polygon, and after this to smooth the frequency polygon to get the smooth curve. Always total frequency is large over here, and when we adopt narrow class interval, frequency polygon will be smoother surface. And if the total frequency is increased, frequency polygon will approach a smooth curve. So, delete. The class intervals are marked on the x-axis and the frequencies is represented there, and we will be joining the midpoint with it. Next graph is the archives. What do you mean by archives? It is otherwise known as the cumulative frequency curve. There are two types of cumulative frequency that are there. One is less than archives. The other one is that greater than archives. To see, it is a graphical representation of cumulative frequency distribution. Less than archive start with the upper limit of the class and go on adding the frequency. These frequencies are plotted while drawing rising curve will be formed, and it is known as the less than archive curve. Now let us see how it will look like. First, in the graph, put the upper limit on the x-axis and mark the cumulative frequencies on the y-axis. Then plot the points x and y using upper limit and their corresponding cumulative frequency. Then at the last, join the points by a smooth freehand curve. It looks an elongated S. For example, see the frequency. So here what we need to do, first we need to write the class interval and its corresponding frequency. Then we need to find out the cumulative frequency. So here we could see that the first one is 0 to 10 marks obtained by the people. So how many people are there? 2. And the frequency is 2. Next is the 10 to 20. The people who comes within this range is 8. So cumulative frequency is 2 plus 8, it is 10. Similarly, the students who got marks in between 20 to 30 is 10. So we add 10 plus 10, so we get the cumulative frequency representing the 20 to 30 class interval is 20. Similarly, 30 to 40 is frequency is 20, cumulative frequency is 40. How we got it? 20 of the previous plus corresponding 20. So 20 plus 20 we get the 40. Same way, 40 to 50 is the frequency is 10. So 40 plus 10 is 50. 50 to 60 is 20. So we get the cumulative frequency as 70. Now let's see how to draw it. So what we need to do, take the upper limit. So here we could see that 10. Upper limit is 10. 10 to 20 is 20. 20 to 30 is 30. These are the upper limit of the class interval. So on the 10, you represent that cumulative frequency. So we could see that x-axis 10, 20, 40 or 30, 40 like that it goes. Here 20 is the difference, but in between it is coming like a 20, 40, 60, 80, no problem. And the cumulative frequencies are going like with the 20, 40, 60 up to 100 it is coming. Here what we could see is the cumulative frequency 2 for the first intervals, that is 0 to 10, on just on the top of the upper limit, that is the 10, we represent the 2. Then keep on adding 10 to 20, 20 side it is 10. Next coming 20 to 30, that is the 20, representing 20. Same way 30 to 40 class interval, it is the 40. We could see that it is coming to 40. So it goes on. Okay. So what do you mean by less than? So we take how we interpret. How many observations are there less than, or how many people have got less than 50 marks? So here we take the 50. So the range is 50. So we take the points. 50 is the cumulative frequency 50. So 50 people got less than 50 max. Got it? Once again I will tell you. For example, 30 to 40. The cumulative frequency is 40. And we know that class interval upper limit is 30 to 40. So 40 is the one there, we will represent 40. Okay. So from this we are interpreting how many people got less than 40 max. How many got? 40 people got the mark less than 40. Got it? Same way, how many people got less than 20? 10 people. How many people got less than 10? 2 people. This is what is known as the less than curve. But remember, in this less than curve, we take the upper limit of the class interval and keep on adding the frequency and we present like. Next is more, greater than or more than. Okay, on the just opposite. So here instead of upper limit we start with the lower limit of the classes and from the total frequency subtract the frequency of each class and plot, we get the declining curve, and this declining curve is known as the greater than or curves. So here how we represent how many children got less than or how many children are got more than this particular class interval. That way we interpret the data. So here we use the lower limit of the class to plot the curve, and let's see how to plot it. Put the lower limit on the x-axis, mark the cumulative frequencies on the y-axis, plot the point x and y using lower limit and their corresponding frequency, and join the points by a smooth freehand curve. It looks an upside down S. So let's look at the picture of greater than and less than. So this picture will give an idea. So which one is the greater curve or which is the less than curve? Let's see. So greater than or more than or curves. So what is there? The class interval will be on the x-axis, frequency will be the y-axis, and the lower limit of the class interval is marked with its corresponding frequency. So here how we did, for example, if it is in the 10, the lower limit, or the 10 to 20, whatever it is, how many people are with the less than that, the corresponding frequency. On the other hand, this is the less than curve. How many people are more than the upper limit, and here upper limit is marked on the greater than or the more than or curve. Lower limit is marked. Got it? So from that lower limit, how many more are there? How many more are there? How many more are there? With respect to the class interval it is shown. Next and the last graph is none. Before that, let's discuss some of the advantages, because we can compare with each other. It's not affected by dynamical size of the class interval and adapter for interpolation. Next, last one is the line graph. The data is collected over a long period of time And the series at the same time we want to show different figures, which is always a line plot or line chart by using the lines to connect the individual data points that display quantitative value over a specified period of time. It shows the trends of event with the passage of time. Let's look at the picture. Number of road accidents in the year of 95 to 2001, and it is plotted each year 96, 903, and two different places so that we can compare it and see how it's the trend over this particular. So to conclude, we have discussed about the different types of graphs like histogram, frequency polygon, frequency curve, and cumulative frequency like ogives, under the ogives, greater than ogive and less than ogive, and the line graph. For the further reference, these are the books, and if you find it useful, please like my channel and subscribe for more channel. Thank you.